For learning objective 4.5a, I'm going to show you how to solve less than absolute value inequalities. Now this works very similar to solving absolute value equations, but you actually have to graph the final answer on a single number line. So let's just start like we did before. Remember, the absolute value is all by itself, so I break this into two. The first one is going to be x plus 3 is less than or equal to 7. The next one is going to be x plus 3. Remember, the 7 would become a negative 7. So we did that. But there is one little twist here. Because I made this negative, in theory I kind of multiplied by a negative. Therefore, remember, on inequalities, you must flip this sign. So you have to come in here, this is less than because it points left, and change it to a greater than or equal to. And let's solve it. So to solve, I'm just going to subtract 3. So x is less than or equal to 4. Here I'm going to subtract 3. So x is greater than or equal to negative 10. Now typically they will graph these on a number line. So I'm going to sketch a number line right here and remember what we did. I'll put 0 here, 1, 2, 3, 4, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, negative 10. Okay, to sketch this one, remember open or closed circle at 4. It has the equal to, so a closed circle. To sketch this one, also a closed circle at negative 10. If the variable comes first, you can just shade in the region or the direction of the inequality. This points left or is less than, so in theory it goes this way. X is first, so I can just go in the region of this. It shades to the right, so from the negative 10 it shades right. So all of my answers for this absolute value inequality are anything that falls on this line. Or, remember, for graphing, you can also think through it. On this one here, it says you want the x's less than or equal to 4. Well, when you're at 4 here, the numbers that are less than or equal to are to the left. Then over here, it says x is greater than or equal to negative 10. So anything greater than negative 10 is to the right. And you would get the same answer. Let's look at another one. So again, just starting off, breaking this into its two inequalities without the absolute value symbol. It can't be there, by the way, otherwise that's wrong. Then it's going to be x minus 1.5. Switch your sign because I'm going to make this a negative 4.5. To solve, I'm going to add 1.5 to both sides. Gives me x is less than or equal to 6. This I'm going to add 1.5. X is greater than or equal to negative 3. I'm going to graph these on a number line. I'm going to put 0 here, 1, 2, 3, 4, 5, 6. Put 7 and 8 there so we can see it. For this first one, I'm going to do a solid circle at 6. I want the x's less than, so I go this way. For this guy here, solid circle at negative 3, so I actually have to go back more. There we go. Solid at negative 3. I want the x's greater than or equal to, so I go this way. So the common region we're going to have is everything on here. And this is going to be true every time. Whenever you have a less than absolute value inequality, the graph will look like a line segment. They're going to come together. Let's do one more of these with a slightly different shading. So 2x plus 8 is less than 2. 2x plus 8 is greater than negative 2. I'm going to solve them both at the same time again. To get x by itself on both, I'm first going to minus 8. That leaves me with 2x is less than negative 6. 2x is greater than negative 10. To get x by itself, divide by 2 for both. So I'm going to get x is less than negative 3, and x is greater than negative 5. On a number line, put 0 here. This is a negative 5, right? Check that. So 1, 2, 3, 4, 5. Put negative 6 here. I need to go to x at negative 3 and put an open circle, x at negative 5 and an open circle. Here I want the x is less than negative 3, so I go that direction, or I just go the same direction as the inequality. This inequality points right. I want the x is greater than negative 5. That's going to be right here. So it's that line segment.